Hello, my name is Bryce McCourt, and this is my presentation regarding my lesson plan of the instructional strategy I would implement as I was teaching the periodic table of the elements. And first, I would present the learning objectives to the students. So first, students will understand the importance of the periodic table of the elements and the information the table gives us about a particular element. Second, students will identify and name the different families of the periodic table. Third, students will be able to determine the number of valence electrons in an atom by determining which group the element is located in. And finally, students will apply the concept of periodicity to the periodic table of the elements. And first, I would explain to the students they would be presented with this blank periodic table. And to go about the direct instruction, we would go through together and label each of these parts. And I will just give a brief overview of how I would go about this. And first, I would explain to them that every single one of these boxes is an element, and an element is only made up of one type of atom. So for example, the first one that you see here where it has the two little baby number ones by it, that is the element hydrogen. And H is the symbol for hydrogen, the element symbol. And then below hydrogen is its name. And then the number that is below the H, that is its atomic weight or its atomic mass. And then the little one that is in the upper left-hand corner of hydrogen, that is its atomic number. And the atomic number represents the number of protons within each element because the protons are what makes each element so unique. And that is information that we can get from the periodic table for each element. If we will go over here to helium, and we'll first actually go back here to lithium since helium's kind of hard to see. Lithium is right below hydrogen, and lithium has the element symbol of Li. Its name is also there below it. And then below the Li, that number is its atomic weight or the atomic mass, how much it weighs all together basically. And then that little baby 3 that's in the upper left-hand corner, that is the atomic number. And since it's 3, that means that every lithium atom will have 3 protons. And that is what makes a lithium atom unique. And because, for example, hydrogen and lithium, they're all in this same column, okay, all of these elements in the same column, okay, they are going to have properties that are similar to each other, and that is the example of the periodicity, where there's repeating patterns, there's similar properties, and that's why this periodic table is organized the way it is. And another way we can get information from the periodic table is looking at other numbers. So for example, this one that's right above hydrogen right here, that means that it is in group 1. So everything from hydrogen and lithium and Na, which is sodium, all the way down, that is, all of those elements are in group 1. And since we can specifically say that that's group 1A, then we can say that the group 1A will have each of those elements will have one valence electron, and the valence electrons are the electrons in the outermost shell. And because all of these elements are in this same column here, that means that they have similar properties for the most part, and we can give them a name. We can give them a family name. And any element that is located in group 1A is called an alkali metal. It's called an alkali metal, with the exception of hydrogen, because hydrogen can be, in a way, unique. So again, there's exceptions to these, but basically everything in group 1A from again, with the exception of hydrogen, from lithium all the way down, the Li, that is the alkali metals. And if you would look at the numbers here on the side, so the 1 and then the 2 beside lithium, that is representing the period number. So for example, hydrogen is in period 1 because it has the 1 beside it. But right below it, lithium is in period 2. And then right below it, Na represents the element sodium, and sodium is in period 3. And then I would show the students, after we would go through this for every single one of the elements, I would then, after we would color code it and label it accordingly, I would actually show them an example of a periodic table that has all the numbers down, has all of these color codes, and all of these colors are representing the different and unique element families